Welcome everyone to the AWS Public Sector Summit. I'm Layla Nouri, and welcome to this session entitled The Future of Fraud Detection and Risk Modeling with AI and ML. First, a couple housekeeping items. The door at the back, the main door, is your fire exit. We do ask that all of you silence your cell phones for this session. And please do download our mobile app. There are session surveys at the end of every session that you can complete. We do value your feedback and act on it, so highly encourage you to fill that out. And without further ado, I'd like to introduce our speaker today. Raghu Raman is Senior Director at FINRA. Over the past 15 years, he has served in many roles at FINRA in the technology division. He oversees a large team of data scientists and engineers working on software to identify behaviors of regulatory interest to FINRA's Market Regulation Division. He works with a multi-petabyte data footprint that is truly integrated in the AWS cloud environment. He and his team currently work with the machine learning and deep learning technologies to provide cutting-edge capabilities to FINRA's business. Raghu?
Thank you, Layla. Good afternoon and welcome. Meet my colleague, Brad. He's a wizard in the Market Regulation Division of FINRA. He can look at market event data and probably tell you what the broker had for breakfast that day. That good. Not too long ago, he came across this news item. It's just one of many that he reads. It's comforting news. Some sort of manipulative behavior was sanctioned. This is good. And there is a reasonable expectation that the parties would not indulge in such behaviors again. Pretty good. But being very intellectually curious, Brad thinks to himself, what are my unknowns here? We do a good job, but then can we get better? In FINRA, the answer always is, yes, of course we can do better. So in a few minutes, we will look at what we did in terms of working with Brad to make it better for him. In the meanwhile, meet Jamie. Wicked smart, extensive experience in the member supervision division of FINRA. These are the types of news items that are of interest to her. She thinks anytime we help a senior citizen, that's good karma right there. We absolutely want our Nana to keep her savings. This is cool. It's very good. She, again, like Brad, every time an opportunity like this comes up, thinks about, can we do things better? Well, of course we can do things better. And we will look at the types of problems that Jamie encounters, how it is different from the type of problem that Brad encounters, and figure out what we have done in the recent past to make it all better. Hint, it uses the latest technologies, ML, AI, whatnot. What is common to these two scenarios that we just talked about is data. For those of you that may not know, FINRA is a private sector, not-for-profit regulator. We have a mission of investor protection and market integrity. We surveil most of the equities and a lot of the options market. We have a lot of industry members that we together call, that you might be aware of as the brokerage industry that we surveil. We take our mission really seriously. But as part of fulfilling our mission, we have to handle and process a lot of data. So by definition, by nature, and by need, and by necessity, FINRA is a large data processor. We cannot predict the future, but we know a few things are absolutely going to happen. Data only is going to grow in volume. It is going to grow in complexity, And we are going to have to deal with it and get better because we will be called upon to get more efficient, to get more effective, to fulfill our mission in more effective ways. We don't need any predictive algorithm to say this because we know this is coming. And we are prepared for it. The way I think about it myself is, if say 15 or 20 years ago, I thought of the way we handle data as the equivalent of me carrying my Chihuahua up my driveway, today's data is like carrying a gorilla up Kilimanjaro. It gets that way all the time. 15 years from now, it's going to be Mount Everest with 2 gorillas on my back. We want to be always prepared for this. Before we get into the cool stuff that we do for Jamie's and Brad's in our organization, we need to talk about all the foundational technologies that make the cool things happen. Because without those foundational platforms, the other things do not add business value, even though we may try to bring them in. So let's take a few moments to figure out what we have been doing. Let's start the story maybe 15 years ago. We were operating a traditional relational database management system. All of our data would show up there. We had these massive Unix servers, state of the art for then. The servers are attached to storage area networks. We processed it. It worked well for a long time, but we absolutely knew we would exceed the capacities of this system. So starting 2007, we moved our big data workloads. And oh, by the way, FINRA has been doing big data long before the term became popular. In 2007, we took all of our big data workloads to a data warehousing platform. We had all these massive parallel processing architecture servers, and it was a good jump for us. We liked it, it was good. But what we quickly discovered was that all these appliances running data warehouse software, they scaled vertically. What that meant for us was, you buy a machine that comes together with compute and storage resources. But once you exceed either the storage or the compute resources of the machine, you got to then buy one more. That's what we mean by it tends to scale vertically. And we knew we would exceed the scale of those machines. What happens if we have more data than machine A? We had to go to machine B. But then the compute resources here may be idle. What happens if we want to share data between the 2 machines? Became problematic. So we knew we would outgrow this pretty quickly. Again, no future prediction required. It is just going to happen. Starting in 2013, we started looking at the cloud. This was very promising for us. And we said, we got to do something. So we ran a bunch of proofs of concept to see if that was the technology for us. Sure enough, within about 8 to 10 months, we discovered we want to be in the cloud. We went all in, starting in 2014. We undertook a 2-year project to take all of our market regulation data and applications to the cloud. I got to say, we are very happy with what we did. It was a huge effort, lots of elbow grease, totally worth it. Along with that, something interesting happened. We discovered that in the cloud, as long as we put in enough effort, we could separate data from compute. What we ended up doing was creating a huge data lake for all of our data. When we did that, we could then bring compute to the surface of the data lake to act upon the data. This was a huge paradigm shift for us in a very good way. We thoroughly enjoyed it. As an artifact of working with relational systems and data warehousing systems, a lot of our business logic was in SQL code base. But once we figured we could separate data from compute and that we could operate with different technologies that would bring to the surface of the data lake, we were able to start moving towards Hive. And when Spark came in, we moved towards Spark execution engines. Together with that, we moved away from SQL. We started adopting modern languages like Scala and Python. All this was made because we were able to separate data from compute. Big deal. In addition to that, cloud brought us a few other things that we are really happy about and that we really leverage for all the latest technologies that we bring to bear for Brad and Jamie. Reduce cost, of course there is that. But as technologists, we are interested in a few other key features. When it comes to scalability of the cloud, what we find that we have more than 10 times the capacity in the cloud than we ever had in our data center. This is huge because the production workloads can work anytime that the operations folks want to run them. Our data scientists have no problem because they don't have to share compute or data storage device bandwidth with anybody. This has been a game changer for us. The elasticity of the cloud was something new for us, but we thoroughly enjoy that as well. On a daily basis, on an average, we run 25 to 30,000 nodes to get our workloads done, and then we shrink it back to almost nothing, and we only pay for what we use. That was an eye-opener for us of the way we can run in the cloud. That was huge for us. Our innovation has moved to the cloud. What we mean by that is our data scientists have full access to whatever it is that they need to do, data-wise and compute-wise. We, of course, have data security, IAM, which is identity and access management. All that is there. It's not free for all. But in prior platforms, one thing we discovered was that a lot of our data engineers and our data scientists, they spent a lot of time on the logistics of figuring out what data is there, where it is located, and the logistics of working with that data. That is not productive time. We define productive time for data scientists as the effort required for them to add business value. Anything else that they do is just busy work required to get to the productive time. We try to minimize that. And to do that, we created a brand new data management system. We, in fact, outsourced it. It's available on GitHub. We call it HERD, H-E-R-D, HERD. And that provides us with data versioning. It keeps track of data lineage. We register our schemas in it. People can auto-discover, people meaning our data scientists and our engineers, they can auto-discover the data, and then as long as they have access to it, they can utilize it, no questions asked. They can create their own little data marts, they can run their experiments, throw it away. They're done. Automatic policies get applied for how long the data would stay, and then in which AWS system the data would say, is it S3, is it Glacier, all automated. We automated the heck out of everything. That has been a game changer. So with these foundational technologies in place, let's see what we can do for Brad. Conceptually, because Brad works in the market regulation division of FINRA, let's think of this as the universe of market data that Brad has to look at. All the events in red, those are of regulatory interest to Brad. Other items, not so much. This is just a concept, just to illustrate the point, just for us to have the conversation. In reality, it is extraordinarily complicated, not even worth talking about in half a day. It'll take 15 to, I've been in FINRA for 15 years at this point. I don't understand 10% of it. It's huge. Conceptually, though, it is very clear, very simple. Items in red, regulatory interest, we want to drill down. Other items, we don't care. Not that much anyway, it's just market context. It's all there. Traditionally, what Brad had was this. We call it rule-based inferences. Again, this is just conceptual. What rule-based inferences boil down to is setting up some thresholds. In this case, just to illustrate the concept, let's say the threshold is a horizontal line that you can see right down the middle. Anything above the threshold, the system presents to Brad and his team for a drill down, further analysis. Hey, take a look at it. We think this is of regulatory interest to you. Anything below the line, the system does not provide automatically to Brad and his team. You can immediately see the problems with this mechanism. Why should Brad and his team be provided so many green items? It's a waste of the time. The moment the system provides it to them, they're going to have to look at it, but they're going to have to discard it. but they just spend time with it. That's not what humans should be doing, to discard items that they should not be seeing in the first place anyway. Okay? Next problem. Below the line, there are so many red events. Hey, how do you go after those? Well, humans have to spend effort trying to go after that, pinprick the system, pinprick the data, manual work. Oh, we got one more problem. Why draw the line there? Why can't the line be further up or further down? Regardless of how judicious you get, regardless of how much effort you put into drawing the exact line, it could still be argued, hey, the line could be elsewhere, depending on what you want to optimize on. These are the problems that Brad faced with rule-based inferences. Brad's question always is, can you do better? Well, you know the answer. Of course we can do better. Let's see what we can do. Starting in 2016, once we moved to the cloud, we started investigating what machine learning technologies offer for us. Speaking conceptually again, rather than drawing a threshold, we can draw squiggly lines and we can draw circles. The more sophisticated we get, the tighter the circles are to capture just the red events, and the more numerous the circles become. Now, we could use linear regression, logistical regression, random forest, whatever type of algorithm that's available to us via the ML libraries that we enjoy at AWS. Sure. And that gives you significantly better and better results. What happens is you capture more and more of the red, and you reduce the green items that we present to Brad and his team for further investigation. Essentially, what we did was we reduced the number of false positives so that there is no waste of time, and we reduced the number of false negatives so that Brad does not have to wonder what the unknown is. His team, Brad and his team, do not have to necessarily go back and say, well, let's look at all the things that the system missed. So we can get really, really, really good with this. An interesting thing happened in our journey through the ML world. Mind you, we spun up a lot of projects. We took a lot of effort, a lot of elbow grease in cooking up various machine learning algorithms to go after all the behaviors that are of regulatory interest to us in the stock markets. We did a lot of work. Along the way, we discovered a very curious thing. We started discovering that drawing these squiggly lines and the circles exactly where we want them, way, way, way more difficult than drawing a threshold. Our data scientists and business experts like Brad and his team spent hours every week. I got curious about it, and we started looking at why are these guys spending hours about something that previously used to be pretty quick. This is what they were doing. We have a 30 petabyte data footprint. It is absolutely an engineering feat to run some software program against this massive footprint of data and pick out the exact slice of data that you want to observe for any given situation. So don't get me wrong, getting this data real time is a really big deal. However, not the point. When the data scientists and Brad and his team started getting together to figure out where to draw the circles and the squiggly lines, this is what they would do. They have data in grid format. They would start highlighting rows of interest. They would try to visualize what happened in the market. This is market reconstruction in your head. What happened in the market, and these are all complex activities, what happened in the stock market that generated this data? That's point number one. Then try to figure out, is that activity of regulatory interest or not? That's point number two. And then try to convey that to the data scientist, point number three. And then the data scientist has to figure out a way to use machine learning to say, I want to capture it, or I specifically want to avoid it. In about a 1 hour session, they would probably go through maybe 2, maybe 3 scenarios. Huge amount of elbow grease. We said, we need a brand new vocabulary to get better at this. So What do you think? Can we get better? Of course we can get better. Let's take a look at this. Outside of the x-axis, where you have time, by the way, that goes all the way to microseconds, on the y-axis, where you have price, no other number in the chart. Beautiful, isn't it? Let's just take 30 seconds to figure out what the chart says. The line in the blue is connecting all the points where market participants are indicating a willingness to sell a particular stock over time. The pink line, that represents market participants willing to buy the same stock at certain prices over time. The big white X, what's going on with that? That's what we call a transaction or an execution. You can immediately see that the moment that white X transaction occurred, the price dropped. The blue line dropped, the pink line dropped. Why? Oh, this is of interest to Brad. Why in the world did that happen? What are the other transactions surrounding that sale or purchase that caused it to happen? That is market context, folks. You try to extract that straight out of a grid data, you will go bonkers. And we did, and we no longer wanted to. This, at a glance, tells us exactly what happened, what drove the prices up, what brought the prices down, and oh, by the way, the very light gray circles and other squares that you see, that represents all the other people that were in the market but slightly more passive. They were not actively pushing up or pushing down the price of the stock. The first time Brad and his team saw this, they said, whoa, 30 seconds. They were done. They said, yep, we want this. The same thing would have taken us 20 to 25 minutes to figure out. And we would have differing understandings of what really happened in the market. This, on the other hand, Vulcan mind meld. We got it. We totally got it. That's how that happened. We set out wanting a new vocabulary. We ended up with a whole new language, the Vulcan mind meld language. We now have a catalog of charts to be used under different market conditions to represent different types of behavior during different ways that the market behaves. And all of our data scientists have absolute power to use anything from the catalog anytime they want, and the users love it. That is freaking awesome. One more thing. Being a curious bunch, our data scientists then started thinking, what did we just do? We took market event data. We call it time series data because the data changes with time. So we took time series market event data, represented that as a shape, showed it to the business experts, just like that, figured out if it's of interest or not. Wait a minute, is this not what deep learning neural networks do? If they can identify human faces, if the same neural networks can identify cats, dogs, and such, is it possible at all to take our time series data, push it into a neural network like shapes, and then say, hey, give me shapes of interest? Can we do that? That was the curiosity expressed by our data scientists. This is what they did. On the left side, you see items of regulatory interest to us. Those are the shapes represented by market data. They said, oh yeah, we want those. The green highlight in each of the charts, that's just to let you know, what we are looking for is a convex shape followed by a reduction in price. We call that buy-side gaming behavior. It's a manipulative behavior. We want to know why, if those occur, we want to know when they occur, and we want to drill down to figure out why it's happening. So we took a lot of examples like this and told the neural network, hey, we want more and more of these. By the same count, when we taught the neural network, we said, those other things, yeah, those are examples. Please don't show us. We don't care. So in a really short time, we taught the network to come up to classify these with a stunning degree of accuracy. We were really impressed with how well and how quickly we could get neural networks to identify the shapes. And oh, by the way, all these shapes we can translate immediately back to market activity. We got it right away. This was huge. At this point, we can operate neural networks at scale, at market scale, at FINRA scale for this type of identification. We are very happy. Nothing came easy. Extraordinary amount of elbow grease went into it. A lot of data scientists, a lot of late night work, a lot of wringing the bro to figure out how to go about it. But it's all been worth it. What do we get for it? I tell you, we absolutely get the holy grail, a happy Brad. The fact that we can have a Vulcan mind meld with our users, with our business expert, makes it all worth it. Let's not forget Jamie. She has her own set of problems. If you recall, Brad worked with the market regulation division of FINRA. The complexity for him comes from the volume of data, but it is all structured. For Jamie, who works with the member supervision division of FINRA, she still deals with millions of documents. But remember, I said documents. That means it's all unstructured data. How do you go about figuring out which documents to pick from disparate systems, leave alone then indulge in the task of reading through them and then figuring out what to do? That's Jamie's problem. We get data through various forms that various companies file. We get through documents, which could be Word documents, which could be spreadsheets, which could be emails. People even send handwritten letters that we actually scan, do optical character recognition, and then store. What do we do with this? We'll start with the end result of where we are with trying to get Jamie's problem solved better and better, and then we'll work our way backwards. Remember, it never ends, but here is where we are. If you look at the top ribbon, for a given context, when Jamie says, I want to do X, or I want to know about X, this is what the system does for her. Items in red, oh yeah, red flag, take a look. Items in yellow, yeah, don't forget, these are all here. And then items in blue, it's up to you. You got too much time on your hands, go for it. With various drill down capabilities. This is where we are. Can we do better? Of course we can do better, and we will. But there is a lot of work that happens behind the scenes to come up with this. Let's take a quick look. In the past 2 to 2.5 years, we have built a whole new text analytics platform. The input for our platform is all the data that we get and we collect. Like I said, it's forms, it's emails, it's documents. And then, from each of those, we now have the ability to extract specific entities. What we mean by them, it's actually simple for humans. We can pick out names, we can pick out addresses, email addresses, telephone numbers, things of that nature. Very easy for humans, very difficult for machines. But the advantage for machines is they can do this all day, they can do this all night, and they'll never tire. The second thing we did with this text analytics platform is any document we can read through and provide a human readable summary so that if there is a filing that is 40 pages long, you get a 2-paragraph summary. Then you get to determine if you want to read any further or if it's not of interest to you. All of that was made possible by this text analytics platform. We use a graph database to figure out all the connections amongst different members, amongst different market participants. What that does for us is make the connections, see the connections, who is interacting with whom. what may be of regulatory interest and what is benign. We have the ability to do all of this and present the user with a simple interface. It allows people like Jamie, like I said, wicked smart, extreme expert, but like any human cannot look at tens of thousands of documents. But with this, relevant data is at her fingertips. She can drill down exactly to the extent to which she wants for any given instance and make the right data-driven decision. How do we do this? I'm deliberately keeping this at a high level. This is a high-level architecture. My colleagues, Matt Curdillo and Dimitro Dolgopolov, had a rather more extensive discussion of this at reInvent last year. At the heart of it all, the purple cauliflower. By the way, we are having a debate as to whether it's a cauliflower or whether it is broccoli, but either way. Amazon Comprehend helps us look at each of the documents that we have in our system, extract the entities that are of interest to us. Again, like I said, entities are people's names, addresses, phone numbers, things of that nature that allow us to place context for each of the documents. And then all of those documents we end up storing in S3, and that's what we feed into the ribbon that you saw on Jamie's workbench. Happy Jamie. No, I don't have a picture of Jamie on a tricycle. This is cool work. We are very happy with it. It never stops for us. We are very happy to share our journey because we have the conviction that any enterprise can do the same, and in fact has to do the same. The path taken by any enterprise is likely to be different, but the principles are always the same. And we want to talk a little bit about the principles that we used. Our technology strategy is very deliberate. Anything and everything that we can do that adds business value, we want to. We constantly want to get better. We constantly want to get more efficient. We want that. And that's a core value. It's a core principle for us. As you saw, we spun up a bunch of machine learning projects, but then we took a detour to come up with a brand new vocabulary in terms of visualization. That led us to deep learning. After all, our project was machine learning, but we ended up doing deep learning and visualizations and created a whole new language while we were at it. That's what we mean by curiosity-driven research. If we had stuck with our original plan, we would now have a whole bunch of machine learning-based projects, all running great, no question about it, but we would not have had the visualization capability that we have today. The whole Vulkan mind meld, not so much. We would not have had our foray into deep learning come upon us and naturally become a discovery that we did and entered into. I don't know who to attribute this to, but somebody said, it is a marathon of trial and error. And that's exactly what we do. For us, it's a marathon. We believe in trial and error. We allow small failures. That's okay. If you never fail, that means you're not at the edge, you're not trying hard enough, and you're staying too close within the boundaries, and we don't want that. We want our horizon to be limitless. We want to operate at the edge. The other thing that we did was there is no daylight between our data scientists and our business experts. We talk as often as we need. There's complete fluidity in our conversations, especially with our new language. We absolutely disagree all the time, but every disagreement ends up with, okay, there are 2 points of view. Let's run some experiments and figure out which way we want to go. We love the disagreements because it leads to discovery. That's how we want to operate, and that's a core principle for us. We always approach our data with humility. We never have any foregone conclusions about where it is going to lead us. We have had our hypotheses, but every hypothesis merely triggers research into whether the hypothesis can be proved or not. Nothing is conclusive until we can all agree here is enough evidence to make it conclusive. These are the core principles that we have employed over the past few years as we move away from project-focused and project-driven work to innovation-focused, curiosity-driven work. I'll be happy to take questions. Do you want to use the mic? Or it's up to you.
Sure, yeah. Well, I think everybody hear me. If not, I'll repeat.
Sure.
Bernie Madoff, FINRA, never caught him for whatever reason. Can you, with this investment, can you catch him or someone like him today, tomorrow? That's using the technology as technical as you can get. Thank you.
From a technology perspective, we believe we can. That's a simple answer, because the larger questions about the Bernie Madoffs of this world have to do with policies, with guidelines, with who has jurisdiction. Yeah. But from a technology perspective, it's relatively easy for us. Thank you. Thanks. And we take cases like this really seriously, and we work through it, and we make sure that we have the technology that it takes to make sure that these things come to. Sorry.
You made the comment that the data scientist and the business person should be the same people. I would think that they would have two different skill sets. The business needs to know the business. The data scientist might need to be a mathematician. So that.
I'm sorry if I meant to convey, if I somehow conveyed that they're the same people. They're completely different people with completely different skill sets. You're correct. What I mean is there is no daylight between them. When we consult with one another as often as is necessary, multiple times a day if needed, to make sure that we both propel forward the same way, that we are rowing the boat in the same direction. We absolutely will have differences of opinion. We are very happy to have that conversation. We are very happy to figure out why we are on different pages and then get back together. But you're completely correct. The business experts and data scientists are completely different people with completely different skill sets.
Yeah, can you bring back up the by sliding visual? And
that one, right?
That one after that.
That one?
Yeah, can you explain the positive and negatives more and how this is used?
Sure. So the whole intent of this is, how do we get a neural network to identify shapes that are of interest to us? On the left side, and we have to teach it with multiple examples. You can't just give it one example. On the left side are shapes that are of interest to us, specifically when we are trying to identify buy-side gaming activity. The price goes up, that must be a factor. There is one principal transaction that then causes the price to come down. So if you focus on the green shaded area, there's always a convexity that then goes down within a specific interval of time that we determine. There are multiple ways that this can happen, so these are all just some examples. This is not the universe of examples. There are thousands of examples that we manually work with our data scientists to figure out and then feed to the neural network. As important as the positives are to a neural network, we have to show it what we do not want as well. So the right side block has the types of examples that we really do not care about. Take the top left one. It has a convex shape, but it never dropped down. So there was no triggering transaction that caused the price to go down. So we are telling it, even if there's a convexity, we don't want to see it. All the others have different types of convexities or inverted convexities, and we are teaching the system, don't show this to us, we don't care. Does that do it for you? Cool. Sure.
Thank you. So for the top middle negative example, could you elaborate a little bit more as to why that would be an example that we would not want the network to look for?
So on the negative side?
Correct.
The middle example in the top row?
Yes.
So it has a complete inverted curve. There is no specific transaction that triggered the price to drop. So there are other market activities as opposed to a focal event that caused the price to turn. Because of that, nobody gradually built up the price and then caused it to drop. Normal market activities cause this to happen, so it's not of regulatory interest. Now, to a person operating in the market trying to make a profit, that might be of interest. But for us, from a regulatory perspective, it doesn't look like any sort of manipulation. It is a sort of benign, normal market activity that happens anyway. No big deal. Carry on. That's where we are.
Two questions.
Sure.
When you made your decisions for AWS as your cloud provider, did you look into hybrid cloud offerings? And the second part, do you do anything with the compute, edge compute per se, rather than using the full AWS public cloud?
Let's start with the first one. That was whether we considered the use of hybrid cloud or not, correct? So back in 2013 when we started this, we ran a lot of experiments to include the concept of the hybrid cloud. But in the end, we decided it was just not for us. Many of the reasons for that was we are in the business of creating business value through the use of technologies. We simply did not see any advantage to also continue to run platforms which are now available as services from the AWSs of this world. So we simply decided to exit that business over time. So that was a compelling reason for us to do so. Now, one of the reasons many people do consider hybrid cloud is for security. We looked at that very deeply, which is why we have 100% encryption of all of our data, both data at rest and data in flight. And we believe that we have as secure a computing environment as if it were our own data center. So with that out of the way, there was no need for us to continue to invest in managing our own infrastructure. So we decided for wherever possible, we'll use the cloud and we will not hybridize the environment. One of the other problems that spoke against a hybrid cloud for us is if there is some data sitting in our data center and then some other data sitting in a cloud, in one or more clouds, there will be a time, we have repeatedly faced this, there will be a time when we need the data to gather. There is never a good spot to put it. So we decided data lake it is, managed by Herd, which is our data management system. Anything and everything that can operate that way has to go that way. So it is very simplified, it is very unified, and we get all the benefits of the cloud. So that's the reason we are where we are. In the future, would that change? Totally depends. We absolutely do not predict the future. But we are always willing to look at new technologies as they come up. Should there be business value, we absolutely want that. Sorry, what's your second question?
Second question was, do you do compute on the edge as opposed to the full public cloud environment?
All of our compute is within the public cloud. We use, like I said, 25 to 30,000 nodes. We use a lot of elastic MapReduce. We use a lot of ML, and it's all in the cloud for our market workloads. Anyone else?
Hi, just a question about the mechanics of this classification. So when you are feeding these positives and negatives into your neural network, are you also feeding it in a bunch of ancillary data that you compute about these, or is this what you're representing here, this visual, the full corpus of the data that you're giving it for the positive and negative things?
This is an extremely simplified view of it, but to your point, it's way more complicated.
That's what I was wondering. So like
way more complicated.
How much like extra stuff do you have to imagine in order to get the neural network to be able to recognize this appropriately?
So essentially, conceptually, here is what we have to do. We have to take time series data, make it into the equivalent of, say, MNIST, the modified NIST format, and then feed it in.
Okay.
So for this particular scenario, it probably, for just to run 1 day's worth of data, it probably takes a data scientist about 60 to 100 hours worth of elbow grease just to feed the data into a neural network. That gives you the magnitude of work. And that's just for training it. And of course, in order to scale it and productionalize it, that's a month or two worth of work for a single scenario.
Got it.
But once you have a template, you don't have to rediscover. The second person coming behind you will be a lot faster.
Okay,
Make sense?
great, thank you.
No worries.
Talk about the real world data, like you look at Twitter and other feeds that are coming in.
We specifically do not look at Twitter feeds in any automated way for this one. There are many policy and regulatory issues around that, so we don't want to get into that. For this particular purpose, it is exclusively stock market data that we are entitled to look at specifically for the purpose of our regulatory obligations. So,
Do you tie with the other NLP exercises that are going on to comprehend the forms, the things that are coming in?
sure.
So events occur there, right? People are filing, hey, this company is performing,
Yep.
what have you. So do you guys do, or is there a confluence of that?
Absolutely. So where there is need to tie in activity in the market with any investigation of, say, a brokerage, we tie that up. We absolutely do. However, even there, our need and ability from a policy perspective to go after media data is relatively limited. It has its limitations, and so we don't normally go after it with gusto, so to speak. We have a limited context in which we can use that data, but not otherwise. Sorry.
What kind of validation things are you doing? You're generating a lot of anomalies. that
Right.
May or may not merit. What kind of retrospective validation is like, well, these really were important and this was.
That's a very great question. Anytime we train a model, we put it through extensive testing. Initially, the first round would be with our business experts. So we say, hey, we ran it for a day. This is what it brought out. Can you take a look and see? And we'll go through it together. We'll then scale it to a month to say, does it work? We go through model sensitivity exercises. And then we put it through a regular software development life cycle. During that, assurance engineers come in and take a look at it. And then they work together with data scientists to say, hey, does this all make sense? Because they run it through a battery of tests. And then when things go into the wild, then we look at model drift. Did changes to the market conditions cause the model to produce results that are not bad, that are not great? In addition to that, our data scientists constantly look at all the incoming data anyway to see if there are new things that we need to figure out to draw a new circle around.
And then do you refer that to the SEC for enforcement action?
We have our own enforcements as well.
Okay.
But we also refer certain cases to the SEC where we have certain boundaries. We are only civil. Anything that's criminal, it has to go to the SEC. So there are various policies and rules and regulations that we follow once we discover something that requires further action.
Do you do anything where it's like the SEC, let's say they had these ridiculous numbers, but 100 enforcement actions, or you all had 100 enforcement actions. Do you do anything where you say, well, gee, 70 of those didn't come up via our process? They were independent investigations, et cetera, or whistleblowers, or that sort of thing.
We absolutely have the Office of the Whistleblower in FINRA. We get referrals from exchanges. We also get customer complaints. So we look at all of these put together. But over time, what we are beginning to find is that we are finding less and less of the types of events where our systems did not trap it in situations like this. However, we are completely open to the idea that we're not going to be 100%. We get asymptotically closer to 100%, but we are never going to get there. So we leave all these other avenues open. None of this is a substitute for human ingenuity, for expertise, and sheer elbow grease. And we are very, very humble about it. We accept that as a limitation, and therefore we have all the other avenues open.
Can you, on the microphone here, sorry. When you were describing the solution to Jamie's problem, can you, you mentioned entity resolution as well as document summarization. Can you touch on some of the techniques and the technology and some of the models that you use for that?
And when you ask a question, can you also address, do you have an ongoing rules engine that you're modifying or an algorithm that you're discovering?
Sure, we'll start here. We'll get back to you in a quick second. So we consider all these as a fabric of mechanisms that we use to identify all kinds of regulatory behavior that's of interest to us. So we do not stop other things just because something new came up. It's an evaluation of, is there value to keeping both? Is there value to running both? Or is there value to sunset one of the items because the other is so good? So to answer that question, it's always a fabric. It's never this versus that. It's always, we start with this and that, figure out where the intersections are, figure out where deprecation, if any, needs to happen. And that's an ongoing, on an ongoing basis, we keep on evaluating. After all, there is something to be said for efficiency, something to be said for cost, so we keep that constantly in mind. I'm being told I have less than a minute. To answer your question, that gets really deep into the intellectual property that we developed in order to do the entity extraction. It is tens of thousands of lines of code. We developed various modules over multiple years to ensure that we get the accuracy that we want out of entity extraction. It's huge, but we can take it offline. Sure.
You started in 2014 and it's 2019, 5 years to learn a lot of things.
Right.
If you know what you know today in 2014, would it have taken 5 years for you or would it have taken less time? Or
We moved to the cloud in 2 years. We moved to the, it will probably take less time because it's a path that we can traverse again knowing what we know. It would probably take less time. Absolutely. Thanks, folks. Good day.